It's 1993. You're sitting in a Denny's booth in San Jose at 2 in the morning, coffee going cold in front of you. Across the table are two other engineers, Chris Malachowski and Curtis Preem, and between the three of you, you have an idea, a little bit of savings, and absolutely no customers. You're about to start a company that makes chips for video games. Everyone around you thinks graphics chips are a dead end, a crowded market already full of companies with more money and more experience than you will ever have. You don't listen. You call it Nvidia. The first few years nearly kill you. Your first product, the NV1, tries to do everything at once, betting on a technical approach the rest of the industry ultimately rejects, and it flops so badly that Sega, your biggest partner, quietly walks away. Money is running out. You have weeks of payroll left, not months. Most companies in your position fold right here and disappear into a footnote nobody remembers. There are dozens of graphics chip startups from this exact era that no one has heard of today, because this is exactly where they died. You don't fold. You bet everything on one narrow idea instead of 10 broad ones. Build the fastest, sharpest graphics chip for the exact standard the industry is converging on, and do it faster than anyone else can. In 1999, you release something you decide to call a GPU, a graphics processing unit, a term nobody in the industry had used that way before. It renders images the human eye had never seen come out of a home computer. Gamers notice immediately. Investors start to notice too. But surviving one crisis doesn't mean the danger's over. In 2000, you land what looks like the deal of a lifetime, supplying the graphics chip for Microsoft's first Xbox. It should be a triumph. Instead, the contract terms turn brutal. Prices get locked in while your costs keep rising, and for a moment, the deal that was supposed to save you nearly buries you instead. You survive that too, barely, and you learn something that will define the next 20 years of decisions. Never bet the entire company on someone else's contract again. By the mid-2000s, you're winning the war you originally set out to win. Your chips are the standard in gaming. You could coast here for a decade, selling faster versions of the same thing to the same customers, and nobody would blame you. Instead, in 2006, you make a decision almost nobody outside the company understands, and plenty inside the company privately question. You spend enormous amounts of money building something called CUDA, a way to let your graphics chips do general-purpose math, not just render pixels for video games. At the time, there is no market for this, none. You are pouring engineering hours and cash into letting scientists and researchers use gaming chips to run physics simulations and academic calculations that maybe a few thousand people on the planet care about. Wall Street does not reward this decision. Your stock price goes nowhere for years. Employees who joined for the excitement of gaming hardware watch resources get redirected toward what looks from the outside like a science project with no customers and no revenue. This stretch lasts the better part of 6 years. 6 years of a stock price that refuses to move while you keep funding a bet almost nobody asked for. Somewhere in that stretch, you have to make a choice every single quarter. Kill the program and go back to being a very good gaming chip company, or keep funding something the market has no name for yet. You keep funding it. Then, in 2012, something happens in a research lab that has nothing to do with gaming. A small team of researchers from the University of Toronto enters an image recognition competition called ImageNet, using a type of software called a neural network, trained not on traditional processors, but on 2 of your graphics cards, because your chips happen to be extraordinarily good at the exact kind of math those networks need. Their system, later known as AlexNet, not only wins the competition, it obliterates the previous best result by a margin nobody had seen before, cutting the error rate almost in half in a single year. You didn't build CUDA for this. Nobody at your company in 2006 said the words artificial intelligence, but the tool you had spent 6 painful years building for almost no one turns out to be exactly what an entirely new field discovers it desperately needs. Every serious deep learning researcher on Earth suddenly needs the exact chips you never stopped making. Within a few years, machine learning conferences that used to be attended by a few hundred academics are filled with thousands of engineers from every major technology company, and nearly all of them are running your hardware. For years, larger and better funded competitors had every chance to see what you were building. Intel, the company that dominated computer processors for decades, had far more cash, far more engineers, and far more room to take the same bet on general-purpose computing chips. Executives there were not blind to what you were doing. They simply did not believe a graphics chip company could reshape the future of computing. It was easy to dismiss from the outside. Your chips were still labeled as gaming hardware on every retail shelf in the world, so the story people told themselves was that you made products for teenagers playing gaming gear, not the infrastructure of a coming technological revolution. That mistake, repeated across boardroom after boardroom, is part of the reason no competitor caught up in time. The next decade is a slow, then sudden avalanche. Universities buy your chips, then research labs, then startups. Then the largest technology companies on the planet start buying your chips by the tens of thousands to train systems that can recognize speech, translate language, and eventually generate text and images that feel almost human. Each new wave of artificial intelligence needs more computing power than the last, and there is only one company whose chips and whose software the entire industry has already standardized around. By the early 2020s, a new kind of AI system explodes into public awareness, one capable of holding a conversation, writing code, and generating images from a sentence. Training these systems requires staggering amounts of computation, and nearly all of it runs on your hardware. Companies that once bought a handful of your chips are now placing orders of hundreds of thousands of them, building entire data centers that exist for one purpose: running the chips you spent 2 decades perfecting. Your revenue doesn't grow steadily, it multiplies. You become the most valuable chipmaker in history, then briefly the single most valuable company on the planet, built almost entirely on a decade-old bet that had no customers when you made it. Here's what most people miss about this story. Nvidia didn't predict artificial intelligence in 2006. Nobody could have. What Nvidia did was build a real general-purpose tool with real conviction, years before there was any proof anyone would need it, and refused to abandon it during the years when the market gave every signal to quit. That's the lesson underneath it all. The biggest wins rarely come from perfectly guessing exactly what the future holds. They come from building real capability during the years when nobody's watching and nothing seems to be paying off, so that when the world suddenly needs exactly what you built, you're the only one who already has it. Most companies chase the market that already exists. The rare few build the tool for a market that doesn't exist yet and survive long enough on conviction alone to find out whether they were right. Somewhere out there right now, someone is funding a project that looks like a waste of money to everyone around them. History says some of those people are wrong. History also says a few of them are building the thing the entire world will be standing in line for in 10 years, and they won't know which one they are until the world tells them.